Welcome dear viewers to the video on topic Biorelevant Dissolution Key Considerations. So in this video we are going to see what are the factors to be considered or what are the key considerations for deriving to the biorelevant dissolution media and the dissolution parameters. In this video only the key parameters or key factors will be discussed, and always consider that the parameters will vary from product to product and from the API to API. See, for example, if you are formulating a tablet formulation of API, say example A, and you are also formulating the formulation of the same API like suspension. So your biorelevant dissolution will be different for both type of formulations. So as I always say, dissolution is a product specific test and dissolution is a performance test. So always consider the product and the drug substance properties whenever you are deriving to the biorelevant dissolution media and the dissolution parameters. So let's start with the API related parameters. Always consider the pK of the API. Always have knowledge about the log P. Then pH of the API. Is your API neutral in nature, or it is acidic, or it is basic? Because pH, pK and log P are the key factors which affect the drug absorption. Then polymorphism. Whether the drug substance is amorphous or crystalline, or whether it is having the specific form, whether it is hydrate, whether it is solvent, or whether it is a base type of molecule, whether it is a salt. So all these parameters are clearly understood. Then particle size of the API chosen for the formulation, whether you are using coarser API or you are using micronized API or you are using the nano size API. pH dependent solubility of the API should be evaluated and it is documented very clearly, so that you will know whether your formulation or whether your API is having any pH dependent solubility or not, whether the API shows precipitation at specific pH or not. So precipitation behavior should be understood if any. Then viscous solubility and the equilibrium solubility. See, there is difference in the viscous solubility and equilibrium solubility or saturation solubility. So all these data are required to be evaluated and understood, and data should be there in hand. Then only you can derive the dissolution parameters for biorelevant dissolution testing. Then also one of the important thing here is that you should also have solubility of the API in the biorelevant medias, whether you are using fasted state biorelevant media or fed state biorelevant media, which may be for the gastric and for the intestinal pH range. So if you have solubility of the API in those medias, it will be very helpful for you to understand the dissolution parameters and to derive the dissolution media and the dissolution parameters, which will give you the good biorelevant fitting. Then also have understanding about the oral bioavailability of the API and bioavailability of the same API in the different formulations if different formulations are available. So stability of the API in the GI fluids. Sometimes the drug get degraded in the basic pH or in acidic pH, and that's why this information is required to come up with the biorelevant media. Then SFG and SIF, that is simulated gastric fluid, SGF and simulated intestinal fluid. So always have the data for the drug stability in SGF for 1 hour generally, and for SIF it is for the 3 hours. Then presence of drug in ionic or non-ionic form in the GIT. So from the log P, hydrophilicity and lipophilicity, you can understood the presence of drug in ionic or non-ionic form. See, if the drug is in ionic form, it will be difficult to get absorbed, and if it is present in non-ionic form, then non-ionic form are more lipid soluble, and that's why this get absorbed easily. Then also have the good understanding about the drug permeability. If you can get the data from the literature about the drug permeability, then it is should be uh, readily available whenever you are deciding for the parameters. Then factors affecting dissolution, which are from the physiological factors. So as I have mentioned in the earlier slides, consider that the precipitation is happening for the API or not, whether the precipitation is happening at specific pH or whether there is degradation at specific pH. Then first pass metabolism, GI motility and gastric diseases. So if the gastric disease is being treated with the API which you have formulated, then that gastric disease will affect GI motility and you will not have the good biorelevant fitting. So always consider the pharmacological class of the API, whether it is being given for any gastric disease and whether that disease is affecting the GI motility or peristalsis. Then transport mechanism, whether it is saturation or site specific absorption for the API or not, whether there is any efflux mechanism or whether there is a use of any excipient which affects the absorption. Then sometimes the PGP inhibitors are used into the formulations, or sometimes the efflux mechanism is inhibited by some excipients. So that should be understood. Then mechanism of absorption, whether it is active absorption, passive absorption, and whether the absorption is depending onto the lipophilic or hydrophilic nature of the API. pH at the absorption site. So if the API is having site specific absorption, so what is the pH of that site for the API to get absorbed? Then effect of drug onto the GI motility. So whether the drug is having effect on the GI motility, whether it is promoting the peristalsis or it is inhibiting the peristalsis, that should be considered. In formulation related factors like design factors, it is very important to understand which type of formulations we are making and which type of the state we have mentioned into the label, whether it is to be given onto the fed in the fed state or in fasted state, or whether there is no food effect. So as per the literature you can get that information, and the formulation design factors are required to be considered, because formulation design will affect the dissolution, and dissolution will have impact onto the dissolution parameters. So whether it is tablet, capsule, suspension, solution or powder, then whether it is a immediate release IR, whether it is a extended release or prolonged release or sustained release or delayed release type of formulation, whether it is tablet, pellets, mini tablets, whether it is osmotic tablet, or the design is a GI retentive type of formulation or floating type of formulation, that is to be understood, and it is to be very clearly uh, understood that the formulation behavior will impact onto the dissolution, and that's why the dissolution will impact onto the uh, biorelevant dissolution uh, parameters. Like osmotic tablet, if you are using and you are going to study the impact of pH and GI motility, so the osmotic tablets will resist these changes, so you will not get much biorelevancy by changing the RPM or medium pH. So like that, we have to see whether our formulation is osmotic or a floating type, or if it is a multi-particulate type of formulation, or whether we are using pH sensitive coatings, and which type of mechanism of drug release is there in the formulation. Then if you are working onto the colon specific release, or whether you are having any chronotherapeutic type of formulation, so that information and that understanding should be there whenever you are going to decide the biorelevant media and biorelevant dissolution parameters. Like if you are working onto the pellet and if you are also working onto the tablet like mini tablet, then the GI distribution of the pellet and tablet will be different. Then multi-particulate system will have the uniform release throughout the GIT. Whether while at the another side, if you are working onto the tablet will disintegrate and it will release the drug at once. But if the same formulation is being manufactured into pellet type of formulation, then pellets will have uniform surface area, uniform size, and multiple units will be there, which will release the API in the throughout area of the GIT. So another factor is GI transit time and GI transit time of the specific formulation. Then the excipient like surfactant solubilizers or buffering agents like acidic materials or basic materials are there used in the formulation. This will impact the GI pH and the pH at the absorption site. So the solubilizers and surfactants will impact the solubility, while the buffering agent and acidic and basic agents will impact onto the pH. That's why these factors are required to be understood. Surfactant in the dissolution media and media composition. So if you are having the surfactant in the formulation also, and if you are having a surfactant in the dissolution media also, so that is required to be critically evaluated. State of the dose administration, whether the formulation is for administration in fasting state or fed state or both. So based on that, you should consider the biorelevant dissolution media and the parameters. Formulation sensitivity to peristalsis, media pH, RPM, volume, these factors are required to be evaluated. Then whether your formulation is disintegrating or non-disintegrating, it is very, very important. Otherwise, you will keep on doing the biorelevant dissolution and you will not get the clear relevance between the in vivo and in vitro data. Then whether you have IVIVC, whether you have conducted the pilot biostudies or pivotal biostudies or not onto the same formulation, and whether you are having a good relevance between those dissolution with the in vivo data. So whether your IVIVC is suitable or not, whether it is applicable or not, that is to be considered very critically. So these are the factors which are related to API formulation and physiological conditions of the GIT. So based on this, biorelevant dissolution can be derived and biorelevant dissolution media can be finalized and dissolution parameters can be finalized, so that you can screen your batches which are showing you good biorelevance, and based on that you can go for the biostudies. Also, you can understand the differences of the formulation and manufacturing processes, and you can discriminate those batches for the in vivo studies. So I hope you might have got good idea about the topic from this video, and I request you to please do like, share, and subscribe to this channel. Share these videos to your friends so that they will have good understanding about the topic. And I also request you to go to the channel playlist. Uh, there are different videos on biorelevant dissolution and IVIVC. So thank you for watching the video.